Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Taylor Dolezal, a senior developer advocate at HashiCorp, where I focus on all things infrastructure, application delivery, and developer experience. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer your questions. In today's session, Alok and Caesar have joined us to talk about leveraging the CNCF observability tools for Kubernetes troubleshooting. This is an official live stream of the CNCF, and as such is subject to the CNCF Code of Conduct. Please don't add anything to the chat or questions that would be in violation of the Code of Conduct. Basically, please be respectful to all of your fellow participants and presenters. In short, please be excellent to one another. With that, I'd love to hand it over to Alok and Caesar to kick off today's presentation. With that, I'll turn it over
Thank
to
you, Taylor. So I'm Alok. I'm the founder and CTO of Upscrews, an observability company built on open source and CNCF telemetry. And I will also introduce Cesar Quintana, my colleague, who is the principal solutions architect at Upscrews. Thank you. So the way we thought we would do this is that before we set up the demo itself and go through that, the fun part, I want to do a little bit of setup so you know have the context of what we do. So with that in mind, let me share my screen and bring up kind of set the stage, if you will. Let me find the right one. And let me know if this is coming up.
Cool, that looks good here.
Okay, great. So as mentioned by Taylor, we are talking about how to add intelligence and observability now that we have open source monitoring, right? Going through the standard confidentiality and legal notice, we'll skip over that. Let the stage by revisiting what really has become the challenges of cloud native application observability, right? And fundamentally, this has been happening now for a few years as applications move to microservice architectures. There are three things that we know have started and really added a lot more challenges to the ops teams that are managing them, right? Number one is just complexity, scale, the tiering, there's so many dependencies, right? And the dependencies, as we've shown on red, you've got, of course, the application pieces, could be PaaS services, could be SaaS services, could be Kubernetes container running an application code, it could be serverless, all of them. And then, of course, you have dependence on Kubernetes itself, orchestrating all of these, and then the underlying infrastructure, wherever it might be. So these create tiered dependencies, if you will, from top down, kind of what we call vertical, as well as across. And this is happening all the time. The third complexity is dynamism. Great, we want to be agile, right? We want to add services, change any one component, scale out, scale in, some things drop, some things brought up. That, together with all of this, is like a highly complex distributed system. And just looking at a couple of metrics is no longer sufficient. It's things are changing, things are coming up. You have a zillion dashboards. So the good news and the sort of not so good news is the following. The good news is, thanks to CNCF and open source, pretty much every possible telemetry, from real-time metrics, logs, events, configuration information, traces, flows are all available now directly from an open source environment, meaning OpenTelemetry is an example, open source that has existed now for a while. So that means we can move to the key pieces to solve that problem. What's not so good news? That complexity. The role of observability is changing. It's no longer about dashboards and just alerting. It's how can we help the ops teams get to understand what's happening in real time so they can detect quickly, find the real issues, and get back up and running. It's the same things that you've heard. Mean time to detect should be fast. Don't waste time with false alerts and get to the root cause, mean time to resolution, right? So what we've learned, having been born cloud native ourselves, is what does ops really do if you think about it? What ops does beyond getting all the telemetry is they understand the dependency When they look at an application with multiple services talking to each other, they understand what the interactions are. They know how applications, services are being monitored by the orchestration. They know the dependence of infrastructure. So, really savvy ops teams, SRE teams know that. They also know what's changing, and they apply curated knowledge. They know, a publish, subscribing, or producer consumer model versus a database, what they're supposed to do. They know what to look for, what metrics to look for. They are aware of the app and the dependencies. That knowledge is what they use when they look through the data and sift through whether it's the metrics, the logs, or the traces, right? So fundamentally, when they look for something that's happening, they're looking at the every component, the inbound and outbound, who's talking to whom, what resources and services depending on, all of this. And so they essentially build context to understand what is happening so they can actually detect the problem, isolate it, and analyze and we figure out what the resolution should be. So if you think about, if observability has to be really intelligent, they have to establish this context, this understanding, and surface that from all that, effectively called noise that's coming in, all the data that's sitting in. If you can't do that, then we've actually made the life of a typical DevOps and SRE very difficult. So that's what we want to do. So our thesis is help leverage this data, right? If you look at open source and open telemetry, clearly we know that things like Prometheus, getting information from Fluidity for the logs and pulling into something like Grafana Loki, using Jaeger or open tracing standards, even to get the traces, looking at flows from things like eBPF and Istio, using configuration information from Kubernetes, changes, even the cloud infrastructure data as well as PaaS information, all that's available. Pull that together, so to build that context across all of them, and then help reduce the amount of information and focus on the right information that ops needs, right? So this is probably the one key slide as we get into the demo to tell you doing it. On the left-hand side, what you're seeing is all the open telemetry, all the open source that is available today. You don't have to put proprietary agents and do proprietary instrumentation code, thanks to CNCF, thanks to open source monitoring that's available. So the first thing, as we said, for context, is understand the structure of the application, what we call the application graph, right? So imagine able to automatically build out that structure in real time. So the ops guy doesn't, or even the app developer doesn't have to go around trying to figure out what's talking to or do something exotic to get there. And that graph has to change dynamically. That graph tells you who's talking to whom, what are they dependent on, how is Kubernetes managing it, allocating resources appropriately or not, and how does Kubernetes have access to the type of cloud resources it needs to allocate to the services. And then to really understand what's going on, that context, pull the data, and what we do is something called a behavior model. Profile every component that comprises the application to see what is expected. Profiling is kind of like building a very simple emulator model. And you can look at it, collect the data to figure out, for example, across all the metrics that you collect, all the flows and events, and say, hey, this one, for example, is IO dependent, this one is CPU dependent or mixed, or this one does a lot of calls. So that as data is coming in, as you learn that, this is where ML comes in, you know what to expect because you have the real-time metrics, you have the application graph. So once you have started learning that, over time, in our case, within 24 hours, you start getting a baseline behavior, which gets better over time. You can start looking at deviations. So you don't have to worry about setting thresholds. You don't have to try and guess what the thresholds and start tuning them. First of all, you don't know which metric and what the level is. Let the ML model learn expose that so that we can then analyze it. Again, in context, we know what are the drivers for every service because we know the application graph. So once we have these deviations, whether it's coming from explicit alerts like a failure in infrastructure failure that Kubernetes detects, or application starts slowing down or having a degradation, you put it all in context and then analyze that. We essentially do what we call local detection across the application, and then we call an analysis of what we call dynamic decision, which looks at everything in context, says, why would this happen given what I have seen? So essentially, think of it as almost like an anthropomorphic, what an ops would do when they understand. If we can put all of this in place and automate this pipeline, we have reduced the amount of work that ops spends today trying to understand what is it, what does the application look like, who's talking to whom, when there's a problem there, instead of setting thresholds. And if I do, how do I analyze it? If we can collapse that and reduce that, we have really done the right service to get the right level of intelligence and observability. So this flow, if you think about it, is what we will demo today, using what you're seeing on the left. That essentially build context, understand the application graph, understand the behavior to surface problems, detect it, analyze it in context, using all the telemetry we have, including changes, logs, events, and help isolate the cause. And so that's our purpose of our demo today. And I'm going to hand this over to Cesar because we want to get to the demo and he'll tell you exactly how we leverage open source monitoring and use open CNCF, open telemetry to do this. So I'm going to stop sharing. Cesar, please take it away.
Actually, look, if you could go back to that, we'll talk really briefly about those open source platforms that we're leveraging. If you could share
All right,
that.
I'll go back. I shouldn't have done that. I was a little too hasty there. All right, is that coming up, Cesar?
There it is.
All
Yeah.
right, let's go.
Yeah. So again, everybody, my name is Cesar Quintana. I'm a principal solutions architect at OpsGroups here, and yeah. So to add on to what Alok was mentioning, right? The whole premise of leveraging these open source platforms that essentially the whole data collection layer has been commoditized, right? Observability data is now easier than ever to access, thanks to these, powerful open source, particularly around the CNCF platforms, right? So, what we've set out in mind, right, is to build something and leverage these amazing tools to make everybody's life easier, right? So things like this is an example of our architecture of how we're leveraging all this open source data and all these open source platforms. So as you'll notice here, if you focus on that Kubernetes cluster square on the right side, right, what you'll see is across the top in the green, you'll see your workloads, right? Pod 1, 2, 3, 4. These are meant to represent your own applications running whatever you're doing, whether you're running an e-commerce site, a financial trading platform, etc. This is what you're running inside your actual workloads. But underneath, in that light and dark blue, are the open source tools that are now so common throughout the IT landscape and in the modern application environments. Right. So towards the bottom, with the dark blue, you'll see here in this reference architecture, we're showing Jaeger, Prometheus, Loki. It could be something, this is just an example. We can leverage logs from other sources like Fluent. I think somebody asked about Fluent. It could be Loki, it could be Fluent D. And then we take metrics in from Prometheus, and then traces. We're leveraging Jaeger as a backend for our particular architecture, but we are supporting open telemetry libraries for the client side. So that's one of the really, really cool things about the new standards is that they're now well defined, which means that you could be using a mixture in your environment of OpenZipkin and Jaeger, or the open telemetry libraries themselves, and still have a unified backend where you're able to collect all that data and leverage it and use it, even though you're technically using disparate libraries throughout your enterprise, right? So what you'll see here, how we've architected ourselves to be built is again around these open source platforms. Again, whether it's FluentD, whether it's Loki and Prometheus and Jaeger, etc., they serve as now your data collection and data store. You don't have to go out and pay another vendor, uh, 10, 15x for storing just metrics, right? When you can store them in your own infrastructure, we're all doing the same thing, right? Just putting them inside of a long-term, bucket, right? And so now that's under your control. And so we, for example, Promptail, right? If you start looking upward towards the stack in the light blue, Promptail will run as a daemon set, collect logs from all your nodes and from all your containers, right? And then you have on top of that node exporter, right, functioning as an exporter for Prometheus to grab the metrics from the nodes themselves. And going above that, you'll see C Advisor, collecting data from the containers themselves running on each node. And then we also leverage KSM Exporter, pretty awesome, grabbing Kubernetes object status data. And all those are going to be fed out into Prometheus or to Loki, and if you're using traces, again, to Jaeger. And really, now, even just with that, you've got a pretty darn functional observability layer, right? Now you have metrics and they have traces. Now you can go into different places and look at your logs. But what Alok was mentioning earlier is that smart layer, right? Now you want to leverage all those pieces of data, bring them in together, and do something really, really powerful with having all that context, all that configuration data that we can grab from the Kubernetes API, and then just bring it all together. On top of that, you have metric data, configuration data, performance data and event data from your cloud environments, right? So bringing in things like more and more applications are hybrid, right? They're using whether it's VMs and Kubernetes or serverless and PaaS. You have all these really, really hybrid environments that, again, it's the whole extreme production of data and having one place and easy ways to collect them. And that's really what these open source platforms have allowed us to do, right? But going back to what I was mentioning about cloud, you also want a place where you can grab your data and bring it in. Talking about, again, serverless or function as a service. The PaaS layers, which are only constantly growing, right? You have these cloud caches and messaging services, cloud databases, etc. So, what OpsCrew sets out to do is not only grab that open source data and leverage those collection platforms, but also bring in the cloud data and mesh it all together and build something really, really rich, and then provide actionable data based on that. So what I'm going to do is I'm going to show you a demo of OpsCrews. Oh, sorry, Alok, did you want to add?
Since I had the opportunity to look at the message, someone asked, "What about Fluent D or Fluent Bits?" And everything for well. So let's address that.
Yeah, no. So as mentioned, right, we can take logs basically from whether it's Loki, Fluent Bit is usually the thing, or Fluent D. Those are usually the pieces we run into, right? And absolutely, the whole point is to build a modular, flexible platform where you can grab data from, whatever your preferred variant of that is, right? So yeah, absolutely. OpsCrews particularly provide support for Fluent D, Loki, and a few others as well.
Yeah. So the takeaway message I want to do before we go in demo, so we can address them all across, is as long as we have the source of getting the logs in, the metrics in, this approach will still work. Of course, with OpenCNCF, we don't have to do proprietary agents, proprietary instrumentation. We can be sitting outside without being intrusive. So think of it that way. The real intelligence for observability is not how the metrics got to us and what it is, as long as we have coverage. That's the key. The coverage is all of these is needed. You can't just go on metrics and logs and traces independently. It doesn't give you the whole picture. Otherwise we are one of the 6 blind men looking at the elephant, which is in the room. All right, go ahead, Cesar. I had to say that because I think it's
sure. No, thanks for that. All right, so now I'll share solo. I think you might have to stop.
I can stop sharing, right?
Sure. All right. So let me share. Hopefully you guys will be able to see my screen here.
So I have one proof point. There you go. It's coming up. Excellent.
Okay. Awesome. So so this is our landing page for OpsCrews, and you can see there's quite a few pieces of data here. You might this screen might look familiar for any of you who have used APM tools before. So this is a real-time service topology map. Essentially, we're leveraging, as Alok mentioned, eBPF as well, right? So eBPF allows us to grab this network data and bring it in alongside not only the tracing, which in this case happens to be optional because we have eBPF. But it is the eBPF network data alongside the tracing data, alongside the metric data, alongside the logs, alongside the configuration data discovered from whether it's cloud or the Kubernetes or the virtual machines themselves or the serverless or other PaaS components. It's all brought together in a single place. But we're giving you this real time, excuse me, a flow of how your services are interacting with each other. And I'm zooming in more. Of course, now this is nowhere close to some of the busiest environments, but you can see that it does get busy really, really quick. And that's one of the cool things about having all the configuration data and the really rich data that the underlying tools like CAdvisor collect, is that we get a lot of really rich object data along with the metric or logs. So things like being able to understand the configuration data of these pieces allows us to also extract things like labels and tags. So when you have a busy environment, you might only want to filter, for example, on a particular namespace, right? I might only want to look at maybe the obscure's namespace, and so that really helps you cut down on some of that noise when you're trying to isolate an issue. But going back to kind of our premise, what we're showing here is a mixture of quite a few different pieces of data. You're showing the eBPF pieces. Again, we talked about cloud, so this demo happens to be running inside of AWS. But whatever cloud you're running on, you're going to have that PaaS layer very likely. So being able to collect that data and bring it all together to your Kubernetes environments, and all monitored in a single place is absolutely powerful. So if I click on, for example, that AWS RDS instance, we're talking about the metrics. So if you look at this right side, we're collecting all those individual metrics, the read IOPS and the throughput, et cetera. This is a high level summary, but important, is metrics, right? So I can go in here and look at all the individual metrics. That's one of the pillars, right, of observability. And that's just for one entity. Same thing for a pod, right? This is a pod in the container. So if I click on a pod, same thing. I'm bringing back all this configuration data, all these labels, what time this was created, what host it's running on. It's important to understand all these things because when you're troubleshooting, what time was this pod running? It was supposed to have been restarted 5 minutes ago. Did we actually perform the restart, or was there an issue, doing that rollout of the application? Well, look, it's been running for since a couple months ago. So hey, that rollout wasn't successful, right? Again, we've got metrics as well, and each entity has its own pieces of data, and it's important to be able to look at that data again in context for whatever problem you're troubleshooting. In this scenario, I clicked on this container. It happens to be the Jaeger agent, but I clicked on this container, and now I'm getting additional data that's contextual for that particular container, the ports that are being exposed. But on top of that, being able to see how the infrastructure is working, what things are related to what. So, for example, we have these contextual access to these different pieces, right? So if I click on this 3-layer view, right, what it does is it shows me this particular container, and this pod is running some details about it, the IP address, the image name that it's using, as well as some high-level metrics such as CPU and memory. But also, it shows me what Kubernetes node this particular container is running on, as well as some of the neighbors and those CPU and memory metrics for those neighbors. And then this Kubernetes node is running on top of what cloud instance, right? So when you're troubleshooting, I know I have some instances in let's say you're running K8s and you have some nodes in one particular subnet or one particular availability zone that are having connectivity issues, and you're trying to diagnose, in a single click, you can understand if your container happens to be running on one of those nodes, and things like the region and how much storage is attached to it. But not only that, again, as we mentioned, the ubiquitousness of all this data and the ease of collecting makes it really, really simple to bring it all together. And now we can look at the infrastructure map that we call, which is essentially our cloud map. And now we're looking in the context of this particular cloud instance, and we're looking at this EC2 virtual machine and looking at the configuration of that and the tags, right? And I'm just kind of showing behind the scenes all the open source data that we're actually collecting, and how even that open source data by itself makes it really powerful. But once we combine the intelligence, which I'll talk about in a second, that's where really things really start to take off. But as we mentioned, we're collecting data from the Kubernetes API and from the container. So that's where we're grabbing the individual container metrics and the node metrics. we also have an understanding, for example, at a per node view, right? So instead of looking at it from a kind of application centric view, I can look at the node level. Let's clear out some of these filters. Now, so you see we have 5 nodes running, and now I'm looking at each individual node, and I can see the workloads that are running on top of that node. I can click on metrics and get the metrics for that particular node. So load in just a second, but I'll go back, and then we can actually look at the configuration for the particular node itself. I have some filters on here by default.
Real-time internet issues.
Always fun.
There we go. All right,
Yeah,
so
at least it came.
yeah, so again, we're collecting all the configuration and metadata not only of the containers themselves, but even the nodes that you're running on. So things like the memory the memory capacity, whether the node is ready. So you'll see here like max memory, max storage, what version of Kubernetes are they running? And so here we see that we're running version 117 of the Kubernetes node, which is actually probably a little bit outdated. And the kernel version of the operating system that it's running on, etc. So we're bringing again all this data together, which is really really empowered by all these open source layer tools. We're not using custom agents. We're not doing anything special. It's just leveraging all this data, but bringing it all together in a single place. On top of that, I mentioned that it's important to cover things like PaaS services and serverless. So again, we also collect that kind of data. So you'll notice here you saw an RDS instance. I think I might have shown a load balancer as well. In this case, in this environment, I have an API gateway running with an S3 call out actually via serverless. So you'll see this API gateway, and again, I'm grabbing the data from that particular API gateway, just like for the containers we saw that particular entity's metadata, and for the nodes. Now here's for the API gateway and some of the metrics as well. And same thing for the serverless functions, right? I can see the ARN of that particular serverless function, the region, and I can click on metrics to down to that. So the whole point is to bring something that's all together. And finally, actually, before I show that, I also did mention traces, and let me actually share this screen because I think I'm not sharing that. I do want to show the traces before jumping on to something else. Here we go. So again, we also have our trace map view that we just recently announced, and so when you're leveraging, as we mentioned, distributed tracing, we can collect all that data again all in a single space. And now what we're doing is we're collecting the individual traces, and actually we're doing something pretty cool, which is what we call the trace map and identification of these trace paths. Sorry, Alok, it seems
I
like
don't see your screen. I
oh,
don't
you
think
don't see my screen?
yeah.
Sorry about
Can you
that.
share? Because I don't think they know what you mean by the trace view. Okay, great.
Okay, there.
And I did see one thing. If you are able to bump up the text just a little bit, I saw a couple of comments about that as well.
Sure. Is this hopefully this is a little bit better?
Yeah, I think that should be good.
Okay,
Thank you for calling that out.
gotcha. Let me know if there's still visibility issues, but I bumped it up just a little bit. Um, yeah. So again, I'm just showing off the tracing capabilities again, just bringing everything all together in a single place. You can see here this trace map showing the different interactions from the front end to the ad service to the product catalog service. But one of the really cool things that is kind of unique that we've been able to develop is identifying. A lot of times in tracing, you'll get transaction identifications. Oh, I'm seeing that. Uh, hopefully, hopefully this is a little bit better. I think I've hit the limit of my zooming in capabilities. Sorry, guys. I always wish it was a little bit bigger. Hopefully, this is some sort of visible for you. Um, okay, so we've got the traces, we've got the trace maps, and oh, it looks like I'm getting some too much noise on my machine. So sorry about that. I'm seeing that in the chat. Hopefully turned off the notification sounds here. Hopefully that'll stop interrupting. Okay, so we've got the trace map view, but we're also discovering what we call the trace paths. So these trace paths are not just. Oh, sorry, guys. Give me just 1 second. I'm trying to.
We are still on Slack, guys. That's why.
Yeah, I know there's stuff coming in. Sorry.
Taylor, you know how this goes.
Oh, absolutely, absolutely. It's
We
always
get on
fun.
Slack
There's,
on our
I feel like as soon as anyone goes live, there must be like a hidden button or something like that
so
somewhere, because
what's the
that's when I
turn
start to
on
get a lot of my
Slack, and we are
notifications too.
being pinged on that. So anyway,
I believe I've turned off do not disturb successfully, which I thought I did before the call.
I just shut down Slack. There you go.
My
Sorry, go ahead.
apologies. My apologies to everyone. Okay, so let me head back here. Okay, we have auto discovery essentially of not only the transactions themselves, which you are used to seeing in distributed tracing platforms, but we are also grabbing the identification of the paths themselves. So you might have a transaction, for one of these products that might be a slash checkout, but you might have a different types of checkouts for maybe a class, right? Maybe you're selling a class on your e-commerce site versus a product, right? So even though they're both called checkout, one might go to AD service and another one might go to this checkout service and then product catalog service. So even though they're both named the same, we'll identify those differences between them and then also perform automated anomaly detection and profile those transactions separately from each other, right? So that's some of the tracing. We won't delve too far into this because I want to show really some of the magic behind what we can do now that we have all that really rich open source data, right? So let me stop sharing and reshare my other screen. Just give me a second here. So there we go. You guys should be seeing my screen pop up here any second. All right. All right. So, some of the things that we can do now that we have all this open source data is that we can now start doing anomaly detection, detecting of misconfigurations, misbehaviors. One of the things I actually did not show, if I go back here really quickly, is that we're also collecting configuration data, not only at this kind of high level metadata kind of view, but we're also showing the entire manifest. So if I click, and I'll just show what I did there. If I click on detailed view for this particular pod, right now I'm looking at the actual manifest for this particular pod. So I can look at the details of what exactly is going on throughout without having to go inside the command line and figure out, get a kubectl get pod -o YAML. And this is way simpler. And it also helps keep everything in context and keep you inside of a single place. But now with all this really rich data and knowing, the other thing we do is we have the what we call curated knowledge, because on top of all this, you do need to understand how these systems interoperate with each other and what kind of dependencies they have on each other. That's why we do build that relationship view, leveraging all the data. That's why we want to know what container is running on what pod, and on what node, and what node is running on top of what piece of infrastructure. So we know when a piece of infrastructure is down, we know that it's affecting the container that's hosted on it. And there's a lot of nuance and variance to the kind of problems that can arise. But having, again, this richness of this open source data, it makes it all possible. So I'll show a couple of things that we do. Here, let me find an alert. I think I was looking at this alert a little bit earlier. So I'll explain a little bit what this is, right? So in this case, we have a deployment problem, right? On our particular web server deployment, we're supposed to have a total of 3 replicas. And in this case, and you know what, I'll bump up the text a little bit because I know that was asked before. So we're supposed to have a total of 3 replicas. In this case, we've only got 2 available replicas, and this has been going on for a little bit. So down here, we provide some details. It's part of the shopping cart namespace. It's the web server deployment. And here's some, additional kind of key value pair details. But we'll go to the fun view. I know some of you guys love reading JSON, but I kind of like this the UI just a little bit more. So when I click on this analyze view, what it shows us is what we call the contextual RCA, which is our fishbone RCA, right? So in this case, what we're showing failure categories across the top and bottom that are affecting this particular deployment. So again, all this is being collected just through the querying the Kubernetes API, and then the relationship of collecting the events and the containers and linking all those pieces together. So we have a replica set scaling issue, right? We're having an issue scaling up an additional replica of that particular image. And now we're getting actually a back off restart as well. But this is all really associated to the startup failure, right? And if I click on that, what it's going to tell me is that I have an invalid image name, right? So obscures is spelled with one I, and it looks here like somebody spelled obscure with two I's. And so that's a bad image name. It took us all of what, 3-4 seconds to figure out that one of our replicas isn't coming up because of a bad image name. So it's those kinds of things, the richness of the data that allows us to build these really, really quick root cause analysis pieces into something like obscures, right? So yes, you can do this from the command line. It's a little bit more work. It'll probably take anywhere from, I don't know, 30 seconds to a couple of minutes, but multiply this times 1,000 times 5,000, that can happen in a month. That's a lot of time saved for operations teams, right? And you'll also notice other ones that some of these are more complex, and these are just building blocks to what I'm going to show you in a sec of these individual kind of problem detections and anomaly detections. But you'll notice other categories. So things like a missing config map, right? If you reference a config map in your manifest that does not exist, you're going to have a failure of your pod. So we'll highlight those things, or failed volume mounts, or even bad image tags. I think I might actually have a bad image tag in here that I was looking at. Yeah, so a very, very similar scenario, but for the cart server. If I click on analyze, yep, same kind of symptoms. Replica set scaling issues. We're having back off restarts going into a crash loop. But in this case, we have an invalid image tag. This particular image tag does not exist, right? Now, the other thing that I didn't go too far into, but it really is absolutely key, is machine learning, right? So from all the individual services that you deploy onto your clusters, what happens is that with that data being collected from cAdvisor and from Node Explorer and from the discovery pieces, what we do is we create a really rich uh, uh, behavior model, right? We detect what is normal behavior for your individual services, right? So if you are, we don't just look at one or two metrics like error rates and response time, but we look actually each one of the entities that I've shown you have their own behavior models, and there's a bunch of others that I didn't show you as part of this demo. But things like if you're using databases like MongoDB or a JVM or an Nginx container, right, and then the generic containers themselves, the nodes themselves, they all have their own behavior models, and we pick up a mixture of a lot of different metrics to understand what is normal behavior. And then when we find what is abnormal, we have these types of alerts that are prefixed by ML telling us that there is some sort of ML detected performance violation, right? So if I click on this in this scenario, again, I'm going to get some details as to what happened, right? I get, I know, let me zoom in a bit. Network transmittal bytes increased by 540%, and level 4 bytes for the outbound traffic increased, and inbound transmittal bytes decreased actually. So we don't only detect increases, but also abnormal decreases as well. But just like in the other scenarios, if I click on analyze, I can get a fishbone representation of what exactly is going on with the metrics and why the ML in the first place triggered an anomaly. And so I'm going to zoom out just one piece, just like you saw for the Kubernetes specific deployment scenarios. Now, and in this Fishbone RCA, we're looking at a container view. This particularly the card cache had some deviation in its metrics. And actually, before looking at this, I'm going to go back just to the summary screen and show you down here. If I click more details, as speaking about the ML and all the metrics we take, these are all the different metrics for just the generic container model that we're looking at, right? So again, it's not just one or two or three metrics. We're looking at transmittal bytes, packets in, packets out, memory failures, CPU utilization. All this data, particularly for the container, is again provided by cAdvisor, an open source tool, right? So again, going back to the analyze button, now we're seeing the actual pieces that actually triggered the ML. And so you'll notice that the fishbone has changed from our startup failure. Now we're showing memory and file system and CPU. And so right away we'll show you in red. You don't have to go and look at a chart for this specific thing. It's here, right? So I'm seeing CPU utilization has increased by close to 50%. I'm looking at demand, which is incoming requests. the response time has increased by over 1,700%. I'm looking at outbound supply side. Response time has increased by 2,200% for outbound requests from card cache. And then not only that, our response size has increased from 1 to close to 8 megs, right? And then bringing in the Kubernetes layer, it's this whole image change, right? So again, bringing the data from the Kubernetes API, I can see that I've got a recent image change that's likely contributing to this failing. Now, again, I'm glossing over a few details because in the interest of time, I want to show you guys how we bring, a couple of these things together. This is, an ML alert. And by the way, you can see this automatically chart those important metrics down here so you can see their behavior during the time of the anomaly. And as mentioned, you can drill down into any logs that might be coming in. Actually, I should probably show that. I don't think I did. So here's another example of an anomaly database server. And you'll notice here that you have different contextual access, right? Application state, I'll show that. But we have a time travel capability where with all this data, the metric data from Prometheus, the log data from Fluent, from Loki, the trace data, all this, we build that real-time map that you guys saw and all the configuration data. We take snapshots every 5 minutes, and I'll show you guys that in a second, but you can go back in time at the time how your system was configured during the time of this particular anomaly. In this case, this goes back a day. So if I click that, it'll take me back into 1 day before and show me the entire config of my entire state at that time. But we'll go into that in a second. I can click on metrics to understand the metrics for that database server or any events that are related to that. In this case, I want to show logs. So if I just click on the pod or the container logs, maybe it wasn't logging there, but I do want to show that we have contextual access to the logs. Actually, let me find... I just want to show because I think we did not actually show logs. Let me see. I think maybe Node Exporter will be logging. Sorry?
And Caesar, I saw a couple questions come in on that front. One question was, does OpsCruise enable custom metrics?
Does OpsCruise enable custom metrics? Yes. You have any... Basically, it's any data that's being exposed to Prometheus, right? So as long as data is being exposed to Prometheus, that data can be brought into OpsCruise, right? We're just leveraging Prometheus as a metric ingestion point.
Awesome. And then one other question was, do the ML alerts wait for a particular size of training data before alerting on that front?
So I can answer that.
Yeah.
So typically it depends on, our default is about 1 day, but we can speed it up so we can learn. So, and the only reason I'll say that is because let's say there's hardly any activity on a weekend, you deployed it. You're not going to see a lot of activity to profile it, but the next day it starts increasing. So over time, essentially, we update that. But our default is 24 hours, can be even less. You can make it even a few hours. Just have enough data to get an initial profile, and then we continuously update that.
Yep.
And cool. Thank you.
No, the users don't have to do anything.
I wish I could learn that fast. Accelerate. Like 1 day is good, but yeah, if I could learn like this.
If you saw that generic container example that says, there's about 30 metrics, and you have no way of knowing because there's some calls being made as a problem versus a memory failure suddenly increases. So there is no way a person can do that. That's what the beauty of using the ML to get unknown unknowns. Keep going.
Yeah, absolutely. So the thing I wanted to show is logs because I absolutely did not show that, even though it's super important. But anything that's logging, right? We pick that up from your standard out. But if you click on any, whether it's an anomaly, in this case I'm just showing the pod, right? I have a pod open, and this is what we call the quick view, right? From its quick view, one of the links you have is for logs, right? So I can just click on logs, and that takes me straight into the logs for that particular service. Now this is pretty static logs here, but I can, it is searchable, right? So I can, look for requests, for example, or conversion.
Yeah, the idea is to contextually link it to the problem.
Correct. Yes.
So depending on where we get it from. Yeah.
Correct. Yeah, I think I don't have a problem here that has logs right now, but we do surface that as well. So if you're having an anomaly, you can go straight into the logs for when they're active, and that'll show. Now, what I do want to show with all of this really put together is I'm going to show you an alert, right? So I showed you guys how we collect all the different data, the architecture, right? Again, we're leveraging just purely open source tools here to collect the data from whether it's VMs or whether it's Kubernetes, et cetera, from the application level, the MongoDB exporters or Nginx exporters, as well as the traces, whatever, OpenTelemetry, compatible libraries, all basically built on open source. But now, right, what we have here is again, I also showed you the anomalies on how we do like specific Kubernetes detection, and then I showed you the ML, how we automatically detect performance deviation, and again, lots of different metrics. So in this scenario, we're kind of tying everything together, right? So I have a response time SLO breach on my Nginx service, so I'm going to click on that. And again, here's some details, right? I have an SLO of 5 seconds. My response time is at over 15 seconds. So I want to see what's going on, right? If I click on analyze, what this is going to do, and I'm going to close this. We'll come back to this summary in a second. I'm going to close that piece. What this is doing is now we're showing a slice of the actual app map that we were looking at earlier, but now it's focused on the time frame and in the context of this particular anomaly, right? So your root is essentially here. At Nginx, you're seeing a slowdown, but we've also identified what downstream services are involved, right? So we have Nginx itself, right? So this is the Kubernetes service, the pod, the container, and same thing, service, pod, container for web server, Redis service, Redis pod, Redis container. And they've got a cart server service, pod, and container. You'll notice immediately in the red, we've highlighted. So we're doing fault domain isolation as well. You don't have to call the Nginx microservice team, whoever's managing that. You don't have to call the web server microservice team, whoever's managing that. Could be the same team, could be a couple of different teams. You don't have to reach out to them. You don't have to go inside your tools and look at the metrics for these particular. We're showing you they're healthy, right? So what the data has shown us from the data we've collected from these containers, as well as from the network data and the configuration data, and combined with RML, that intelligent layer of the operations is we've highlighted the red pieces, right? So our container for Redis is red, our card server service is red, and so are our pod and container. So we'll kind of take this in the chain and see what's going on. So we've identified we have an SLO failure up here. We're responding really, really slow. Now, if I click on the next piece in the chain, I'm showing that Redis container is problematic. If I click on that, what it's going to do, it's going to show us this is technically a separate anomaly from the Nginx one, but the ML has detected that this is very much related. And you'll see a few different failures, right? So you'll see that we're getting an increase in throttling on the CPU. The user seconds total spent on the CPU has increased by about 10%. But really interesting, actually, here is you'll notice the response time normally is at 2.94 milliseconds. Right now, we're at over 2 seconds. This was automatically detected. And then also super important is our error rate, right? Basically, you usually have 0 errors. Right now, our error rate has jumped up, to 36 out of every single request has essentially gone into an error mode. So something is wrong. So we're gonna go back here and just see what our RSA is pointing at. So Redis is calling card server. Now, if I click on card server, I'm gonna see the alert very, very clear. This service, the card server, doesn't have any pod to serve requests. That's a very, very clear indicator that obviously our Redis is experiencing a bunch of response time failures and now error rate failures because there are no requests behind this Kubernetes pod. No pods behind this service to serve any requests. And to look into just a little bit more detail, if I click on this particular pod now on the cart server to see if I can glean what's going on, it looks like I'm having a back off restart. And if I look at the details of that alert, it'll actually show me a little bit more detail. Again, these are all separate but linked together problems. If I click on the Analyze tab, now it's going to show me the real root cause, right? We've got an invalid image name, as we talked about earlier. So this broken image name with 2 eyes in India, this is, I'll zoom in a little bit so you can see that. I zoomed in too much. But you can see that Obscures India here showing 2 eyes, right? So we have this invalid image name, and that's really, the root cause of the issue, and it's all shown right here in a matter of seconds. Our Nginx is experiencing a response time slowdown. Redis is saying that we've got an increase in response time and alert and errors. Card server is saying, well, I don't have any pods to serve. And the pod itself is saying, well, I can't start because somebody gave me a bad image name. All this in a matter of, about 20 seconds, right? It took me obviously close to a minute and a half to explain. But all this, understanding the Kubernetes level up to the application level and how they are affecting each other is all powered by these open source tools. Plus, the intelligent layer on top, which is, in my opinion, pretty darn cool. In the interest of time, there are things I wanted to show. I did want to show time travel, but I think we're pretty close out of time. I want to open it up for questions. So with that, I'll turn it back to you, Alok and Tyler.
Yeah, so I think we should go back to Q&A. So if I were just to summarize, kind of just back to the premise we started with, right? In order to really help ops in this new cloud native microservice environment and Kubernetes, we have no longer to worry about where the data is coming from. All the telemetry is there. The idea is to build it, but really what observability has to do to have this intelligence is able to understand the full context of the application, across everything, across all dependency, track that. Users should not have to do that, so that's what we need to build in. And then understand the application, profile the behavior, so they don't have to worry about how to detect problem setting thresholds. We want to take that off the table. And then contextually analyze everything, because now we have rich data in this whole distributed systems, that whether it's in infrastructure or Kubernetes related or down to the application, they all link together. And you don't need 6 different folks looking at traces, logs, events, alerts to do that. That's the role of observability in this new world. And thanks to open telemetry and open source, it is possible to do that now. So think of us as the proof point. You don't need to worry about running multiple siloed tools to really build that intelligence and reduce the amount of effort needed. I'll pause there. That was the whole point of, guys, take advantage of the open telemetry and the open source tooling that CNCF has been helping. We are firm believers in that, and we hope you can leverage it too.
Awesome. Awesome. Thank you so much. I did see quite a few questions come in. I see at least 3. One question, the first one from Ishmael, was how easy is the installation?
No, that's a great question. Let me see if I have it in this environment here. So for a typical deployment into maybe an on-prem cluster, we leverage Helm, right? Again, another open source tool. So I mean, we leverage Helm. It's these commands. It's about 3 or 4. Well, it's actually 5 commands.
And sorry, could you bump that up just a little bit?
Yeah, I absolutely will.
Thank you.
So essentially, if you don't have if you have these existing tools, because a lot of people, as I mentioned, these are essentially the de facto standard for open source monitoring in all these modern environments. Most of the people we run into already have these tools, so it's actually a little bit simpler. But if you don't have these tools, we absolutely, this I think it's this last command that will deploy, all the open source tools if you don't have them underneath already. But essentially, it's through Helm, right? These commands, these 5 commands, and that gets you from a greenfield cluster to up and running. Literally, I mean, copy and paste. I mean, you're up and running in about, I don't know, 3 minutes, 4 minutes, and you have the entire environment that I showed. The only thing that's not available right off the bat is the ML, because again, it takes a couple of anywhere from I've seen ML alerts come back in a couple of hours to 24 hours. This is usually that sweet spot. But everything else that you saw within 3 to 5 minutes of deploying, you're getting all that data. So this is how simple it is.
Awesome. Thank you so much. The next question I saw was, is it free, or kind of what levels? How does it work? Is it a SaaS, or is it something you can host on your own?
It is a
Can you
SaaS
tell us about
service,
that?
yes.
Cool.
Absolutely.
There is a freemium offering for people who want to try it out. So, you can go to our website, opsquiz.com, and check it out.
Cool. Thank you. Next question. We've got lots of questions coming in. Thank you, everybody, so much for submitting those. Please keep them coming. I think we have about 7 minutes, so I'm happy to field those as much as possible. The next question is it a good idea to export this data to do offline troubleshooting by importing data collected? I was wondering about troubleshooting edge deployment cases where we don't have access to the cluster.
Interesting. So you're talking about when you don't have if you can collect those metrics, you're saying, and push it to us. It's a little trickier with this, depending on the context. Maybe you have to dig into a little more specifics, what data, because remember, in order to understand the application context, we pull everything. We'll be able to see the dependencies. So seeing it in isolation doesn't tell you that. So it will probably be specific, so we can take this offline if this attendee has something specific that we can follow up and ping us.
Yeah. I will mention, it depends on how your edges configured. Like if you flat out don't have access to like export metrics, right? I mean, again, Obscures itself isn't really doing much on the collection side. It's really around having Prometheus on the cluster and having Loki or FluentD on the cluster to collect that data. Really, if you don't have access to there, that's something to be explored. But speaking about Edge itself, we have, we recently published like a joint blog with Verizon where we're talking about. And again, guys, sorry, I don't know what's going on with my D&D button. I know somebody mentioned in the chat. I don't know what's going on with my Do Not Disturb. I promise I turned it on. But anyway, uh, we when you're running Kubernetes clusters, for example, at the edge or running workloads at the edge, it absolutely is a supported model, right? Again, that joint blog I mentioned is launching a Kubernetes cluster on AWS Wavelength, and with Kubernetes and observability built in with ops crews, and it functions perfectly fine. But again, if you have like a really really locked down edge, and that might be something that we can talk offline. Feel free to reach out, or we can talk about that scenario.
It's a definitely use case because a lot of the edge applications are deploying in Kubernetes. So we are playing into that space totally.
Awesome. Thank you. Next question is AWS Bottle Rocket supported?
Can you repeat the second part? AWS what? Sorry.
Yeah,
is
so that's
Amazon's operating system Bottle Rocket. I believe that it's kind of built for containers and running things on that front. My initial thought would be yes, because of the interfaces that you've chosen to bind to, CNI, CSI, all of those things. But so long as those are supported, that should be good. But not sure if that might correlate to the system metrics. Might be the specific question.
Yeah, correct. So it should be, I don't remember if there's actually somebody that is using AWS Bottle Rocket, but again, we actually don't delve in necessarily too much into the OS, because as long as they're running like the minimum required kernel, like on the nodes, right, which is I believe kernel 415 of Linux and up. Yeah, I mean we shouldn't have any issue supporting that. If you want to explore, I highly suggest signing up for the free version, and it should work. I don't see why it wouldn't.
Yeah.
So yeah, that's
primarily we look at OSs that will enable collecting flow data like eBPF. That's probably a primary requirement. That's it. And
Cool.
And on those nodes run Node Explorer, of course.
Cool. Interesting. It's fun to kind of see all these different computes and then being able to surface that information.
And it's not just AWS. We work with any cloud vendor. That's the advantage of working without being, looking at proprietary agents.
Awesome. Next question is: does the SaaS support SSO and SAML login?
Yes, absolutely. Yes. So I believe the free version doesn't have like that quality of life. There's some of those things that are like more enterprise features. But yes, absolutely. Many of our customers are using like Azure AD, or they might be using Okta, etc. We absolutely support that.
Excellent. Next question is, promise keep peppering you until we're out of time. What resources does ops crews require? I'm guessing that might be pertinent to like Kubernetes primitives like node storage, deployments, config maps.
You're talking about what is required for just the collectors that we have, right? That's an easy one.
I think it might be more the platform to like install that integration to report the data to the SaaS.
Yeah. So for when we showed the architecture, really, that's it does
might be worth pulling it up.
Cluster, right? But typically, for the actual open source collection tools, I mean, each one has their own requirements, but they're really small. I mean, we're talking about hundreds of millicores to run the open source collectors like CAdvisor and Node Explorer. Those are all really really lightweight. The only piece that utilizes more resources is really Prometheus, right? And that's just depending on the how many objects you have in the cluster. We typically, for a small size cluster, recommend maybe like a two CPU 8 or 12 gig machine. But as you scale up in the amount of objects that I think I've seen just, and I might be misremembering. So if you want more details, like really hard numbers, please reach out. But I think we've seen like close to 5,000 containers being monitored by at this point maybe 64 gig 4 CPU machine node to power Prometheus, and it's not fully used, but sometimes when when you scale out and you get just all those some tons of a spike in objects, that's really when it uses that. But Prometheus is really the biggest one, and you'll find this it's not an ops using, it's a Prometheus piece. But other than that, all those components, I mean, you're talking extremely small resource requirements, really negligible on your clusters.
Absolutely, absolutely. Well, with that, unfortunately, we are at time. I really do appreciate everybody reaching out and asking those questions. Like all good things, the streams have to come to an end, so we are at that point. But thank you so much. If there is anyone looking to kind of reach out to either of you, is there a good place to open up those questions?
Sure, you can reach us to info@obscruz.com to be generic enough. And you can also ping us on the website, obscruz.com itself. You should be easy to find us. We're also on LinkedIn if you want to look at our Obscruz page. Love to chat with you guys, get your feedback.
Excellent.
Hopefully
Excellent.
this was interesting and exciting given where things are going with open telemetry, open source, and observability.
Well, thank you both so much. Thank you, everyone, for joining the latest episode of Cloud Native Live. It was great to hear from Aloke and Caesar. We really, again, love the interaction and questions from all of the audience. Join us next week to hear about how we're going to be building stability in Kubernetes with Andy Suderman of Fairwinds. Thank you all for joining us today, and we will see you soon. Have a good one, everybody.
Thanks, everyone.
Thank you.